In this screencast, I'd like to show you how to start visualizing your data with D3.js. In the last episode, I explained the update pattern, which I will use here again. Instead of translating data HTML elements, however, I will be translating the data to SVG elements. Let's get started. I start by going to the D3 website. They have a little snippet I can use to embed D3 into my site, so I'm going to copy it. I'll be using CodePen.io for this demo, so I'll paste it into the HTML. From here I will be writing exclusively in JavaScript, so I can expand that out. We need some data to visualize. I want to plot some points, so here are 4 points that will work well for us. Next, I want to create an SVG element and append it to the body. I need to set the width and height of the graphic surface so that I know my points will fit in the space. 600 by 400 should be plenty. I always like to put my transformation logic into an update function, so I will create that now and just call it. Now I want to draw some circles. I will select the circles currently in the SVG element, which is currently an empty set, and I will join data with it. Now I need to declare what I want to happen when data enters the set. I want to append a circle and set the attributes. Instead of calling adder several times, a shortcut is to just give adder a JavaScript object instead. I need to set the fill color, the center X and Y values, and the radius. For now, I'm going to keep the Y value constant and bind the data to the X value. I'll keep the radius constant as well. Notice now that I have 4 circles. The order of the data has not been preserved in this visualization, so I'm going to tweak it a bit. I will bind the data to the Y value instead of the X, and I will stagger the X value every 50 points. There. Now the data is starting to take form. To add to the effect, I will bind the radius of the circle to the value as well. Whoa, that's way too big. How about the square root of the value instead? That's better. Next, I'd like to draw a line connecting the points. I'll start by using the same approach, though I'll show you a better way afterwards. Select all the lines, join the data, and define what to do when data enters the set. I want to draw some lines, and a line requires a stroke and a color to begin with, so I will make it 2 pixels and black. A line is made up of 2 points, point 1 and point 2. I'll just rough something in here, and we'll refine it as I go. Now we're drawing some lines. There are 4 of them all in the same place, and I need to fix that. I know that the second point in the line should be the same as my circles. I will extract the X and the Y functions so that I can reuse them. Now, when I use them for the second point, you can see that I'm making progress. The first point is a little bit more tricky. We want the first point to be the previous point of the data. Here is one way to achieve this. I need to create a previous function, which will get the value from the data at the previous index. I need to make sure that the index is greater than 0 because we can't index -1. What if my index is 0? I'll just return 0. It'll work out. Now, I can just say that the first point is the previous X and the previous Y. Pretty cool, right? In reality, this isn't the best tool for the job. Instead of stringing together multiple lines, the vector approach is just to create a path. Luckily, D3 has a path generation function that I can use. I will just declare a line with the x and y values of the functions that I declared earlier. The line variable is really just a function. When I call it with the data, I get a string representation of the path. This is really just a standard vector path used by a myriad of vector drawing technologies. With this function, we can simply append a path to the drawing surface. I need to set the fill attribute to none because paths are filled by default. I then set the width and the color. I'll choose blue so it'll stick out. Then I set the data for the path from the line function. Now, instead of many line segments, I have a single path. In addition, I can take advantage of D3's interpolation capabilities and smooth out the line. I don't need my line segments anymore, so I'll get rid of them. I can also get rid of the previous function because we don't need this anymore. Finally, I'd like to be a bit more idiomatic with my path generation. Similar to how we bind data in a set of elements, we can bind a datum to a single element. I'll assign the entire data set as a singular datum for the path. By doing this, I can just pass the line function directly, and I get the same result because the data is passed to it. That's all I have for this lesson. I will expand upon this example in the future to illustrate scaling, axes, and animation.